Hello everyone, in this lecture we will be going over problem 4 from the IMO 1970. So we would like to find all positive integers n such that this set of six numbers, six positive integers, can be split into two disjoint subsets such that the product of elements in each of these subsets are the same. So obviously by checking mod 5 and divisibility by 5, one of these six consecutive numbers will be definitely divisible by 5, but then it would immediately imply that the answer, because we want their product, the product of the numbers in the two sets, be equal to each other. So one will have a 5, the other one should have a 5 as well. So therefore it immediately implies that n and n plus 5 are those numbers divisible by 5. So n is a multiple of 5 and n plus 5 is the largest one, so that one is also a multiple of 5. So now we would like to check, so those two, their disjoint union would give you this whole thing here. Next, I want to make the observation that in fact these two sets should both have 3 elements. The other case won't work. Well, so let's check the other case. So the other case would be the fact that we would wonder if n times n plus 1 times n plus 2 times n plus 3 would be equal to n plus 4 times n plus 5 in any condition. So where the first set has 4, the second set has only 2 elements. But then it's obvious, it's very easy to show that easily one can show that n times n plus 1 is strictly greater than n plus 5 for I believe whenever n is greater than 2, and in a similar way n plus 2 times n plus 3 easily can be shown that that's definitely greater than n plus 4, and that one is even smaller case, so for n is greater than 1. So therefore so it's easy to check the other cases for n is equal to 1 or 2, for instance. So it's easy to check that this will never hold. So therefore we have 4 numbers left, namely those 4 numbers n plus 1, n plus 2, n plus 3, and n plus 4, and there's only one configuration which makes sense. So namely those where n plus 3 and n plus 4 moves into this set, and n plus 1 and n plus 2 moves into this set. Now let's see if such a configuration will work. So therefore we wonder if the product of the 3 terms in the first set is equal to the product of the 3 terms in the second set. And after you do all the arithmetic and the algebra, so you will get 2 cubic expressions, the n cubes will cancel out. Ultimately that would lead to n squared plus 5n plus 10 is equal to 0, but that has no integer solution, so no easy to check that integer. You can, for instance, use the quadratic formula. Solution. So therefore the answer to the problem is no such configuration. There's no way we can split this set of 6 consecutive integers into 2 disjoint subsets where the product of terms in each set is equal to the product of the other set. And that solves our problem. In fact, this problem is a special case of a more general problem. And the statement of the problem is as follows. If P is a prime of the form, so let me open some space here. So if P has form in mod 4, 4k plus 3. In our case, P is equal to 7, by the way. then one cannot partition p minus 1 consecutive integers into two classes with equal product. As I said, our problem, so then p minus 1 consecutive numbers cannot be partitioned, partition. And as I said again, in this case, in our case, we are looking in this problem, the case where p is equal to 7. But see if you can solve this more general case in your spare time. So that solves our problem. Hope to see you in our next video.